So hello guys, once again I welcome here all of you in this marathon session, and today we're gonna discuss is our new chapter, or you can also say it as a new subject because it is in under transportation engineering. Basically, I'm talking about railway engineering, and today we're gonna discuss about geometric design of railway. Basically, in railway engineering, geometric design of railway is the only thing which is asked in gate examination, which is in the syllabus of gate examination. Otherwise, railway engineering is a very very vast topic to study, but in our gate examination there is only geometric design of railways in the syllabus of gates, so we'll cover only that. Okay, so yeah, let's start railway engineering. In railway engineering, we're gonna discuss geometric design of railway. Geometric design of railway. Okay, in geometric design of railway, we're gonna discuss first is safe speed. Basically, safe speed in case of curves, it depends on a gauge of track, radius of curve, super elevation, transition curve length, and resultant of weight and centrifugal force. Okay, so it is a so let's we move on direct to formula for computation of safe speed. Okay, basically it denoted as Vs. So yeah, formula for wait is it formula for computation of safe speed. Basically we denoted it as Vs. Okay, so for computation of safe speed we have Martin's formula, we have a railway board formula. Yeah, so let's discuss about Martin's formula. So first, Martin's formula for computation of safe speed. Martin's formula. In Martin's formula, we discuss first condition for speed of transition curve. Say speed for transition curve. Okay. So for broad gauge to the for broad gauge and meter gauge, we have a safe speed is equal to 4.35 under root r minus 60 r minus 67 kilometer per hour. Okay. So for broad gauge, let's say it's BG in short form, and for meter gauge, broad gauge and meter gauge, our safe speed is equal to 4.35 under root r minus 67 kilometer per hour. Okay, so yeah, and you know for narrow gauge, this speed is a modified, this speed is our safe speed is about 3.65, and 3.65 under root r minus 6 kilometer per hour. And for broad gauge and meter gauge, this is basically for broad gauge, and we have a speed for meter gauge, which is something, Vs is equal to 4.4 under root r minus 70 kilometer per hour. Okay, and for a narrow gauge, let's say for narrow gauge, we have this vs, we have this safe speed is equal to vs is equal to 3.65 under root r minus 6, under root r minus 6 kilometer per hour, kilometer per hour. In narrow gauge, basically safe speed is maximum of is equal to 50 kilometer per hour, 50 kilometer per hour. Okay, so yeah, this is about for speed of speed for transition curve. Let's move on to the speed for non-transition curve. Speed for non-transition curve. So basically, speed for non-transition curve is 4 by 5 of the above in all cases. Okay, and for high speed, vs is equal to 4.58 under root r, and maximum its value of go to the 40 kilometer per hour. Okay, for narrow gauge. Okay, here in for narrow gauge it's about 50, and maximum it is go to the 40 kilometer per hour, that is 4 by 5 of 50, that is 40 kilometer per hour. So speed for non-transition curve is for say speed is equal to 4 by 5 of the above in all cases, above in all cases. Okay, and for high speed our safe speed is vs is equal to 4.58 under root r, and our maximum speed is 40 kilometer per hour for narrow gauge. Okay, so yeah, this is about all about Martin's formula for speed of uh, for speed for the transition curve, speed for transition curve, and speed for non-transition curve, which is in which is 4 by 5 of all cases. Okay, so yeah, let's move on to our next thing, is that next formula to find a safe speed, which is railways board formula. Okay, railways board formula. Next thing to find safe speed is railways board formula. Railways board formula. Okay, so in railways board formula, is we here we find for speed for fully transition curve. Okay, so we find for speed for fully transition curve, fully transition curve. Okay, so yeah, for broad gauge we have a speed we have speed, this is about 0.27 under root r into ca plus cd. This is for broad gauge, broad gauge. Okay, and for meter gauge, this is about 0.347 under root r into ca plus cd. Basically ca is actual current, and cd is current deficiency. Okay, r into ca plus cd, and this is for meter gauge, for meter gauge. Okay, and for narrow gauge, this is about 3.65 under root r minus 6. This is about 3.65 under root r minus 6. This is for narrow gauge. Okay, and in all this maximum value is 50 kilometer per hour, 50 kilometer per hour. Okay, where one more thing here, ca is actual can't, actual can't, and our CD is can't deficiency. Okay, so yeah, this is the thing in railways board formula to find speed for fully transition curve. Okay, so yeah, for broad gauge this is 0.27 under root RCA plus CD, and for meter gauge this is 0.347 under root RCA plus CD, and for narrow gauge it is 3.65 under root R minus 6. Okay, and its maximum value is 50 kilometer per hour. Okay, so yeah, this is it in railways board formula. Look at about can't to be gained over virtual transition, which is a 14.6 meter on broad gauge, and 13.7 meter on meter gauge, and 10.3 meter on narrow gauge. Okay, so put that thing on also in your notes about can't that can't to be gained over virtual transition, which is 14.6 meter for broad gauge, which is 14.6 meter for broad gauge, and about 13.7 meter for meter gauge, and about it's about 10.3 meter on narrow gauge. Okay, it's about 10.3 meter for narrow gauge. So do remember this thing about can't. Okay, so yeah, this is it for safe speed. we'll we discussed Martin's formula and railways board formula for finding a safe speed. Let's move on to next topic, is that equilibrium speed. What? Equilibrium speed. Equilibrium speed. So it is denoted as VE. Okay. So in equilibrium speed, let's first look into that factors. What are the factors which controlling the equilibrium speed? So yeah, so first thing is factors controlling equilibrium speed. Factors controlling equilibrium speed. Okay, what are the factors which controls equilibrium speed? Basically um, there's 3 to 4 factors, like maximum permissible speed, permanent and temporary speed temporary speed restrictions, number of stoppage gradients, and proportion of slow and fast trains. Okay, so there's a 3 to 4 factors which in which first one is maximum permissible speed denoted as VM, and permanent and temporary speed restrictions is also one of the factor which control equilibrium speed, that permanent and temporary speed restrictions. Speed restrictions. Another one is number of stoppage and gradients, proportion slow and fast trains also. Gradients, yes, proportion of slow and fast trains, slow and fast trains. Okay, Let's move on to, so this is it about the factors which control the equilibrium speed. Let's move on to the next topic, which is calculation of equilibrium speed. Okay, so how we calculate the equilibrium speed. So calculation of equilibrium speed. So for maximum permissible speed Vm is greater than 50 kilometer per hour. Our equilibrium speed V is something is about 3 by 4 to 3 by 4 of the Vm or Vs, whichever is less, whichever is less. If 3 by 4 Vm is less, then we'll choose that. If 3 by 4 of Vs is less, we'll choose that. Okay, so this one is the one as the method to find equilibrium, to calculate equilibrium speed. And our next step for maximum permissible speed Vm less than 50 kilometer per hour, 50 kilometer per hour, then our V is equal to Vm or Vs. V is equal to Vm or Vs, again, whichever is less. It's less. Yeah. So this two condition for calculation of equilibrium speed. And our another thing in equilibrium speed, that average equilibrium speed. How you calculate average of equilibrium speed? So our third thing is average of equilibrium speed. So it is denoted as something like this, VE average. Okay, so it is equal to that N1 to N1 V1 plus N2 V2 plus N3 V3 plus so on plus NMVM NMVM upon N1 plus N2 plus N3 upon N1 plus N2 plus N3 plus so on plus NM. Okay, so this is average equilibrium speed, where N is number of trains moving on same track. Okay, this N is where is N is number of trains moving on same track. Number of trains, shit man, number of trains moving on same track. Okay, and obviously V is our speed, and V, this is an, okay, give me a second. V is speed. So yeah, this is average equilibrium speed. Let's move on to the next thing, which is limits of Kant. Limits of Kant. What? Limits of Kant. Limits of Kant. So for broad gauge, for group ABC routes, it is equal to 165 mm, and for group D routes, it is about 140 mm. And for meter gauge, it is 90 mm, and for narrow gauge, with same condition, that it is 65 mm. Okay, basically, if you uh, I know you guys have a question on your mind, that what is Kant. We'll discuss about a lot about Kant. So what is Kant? Basically, Kant, it is the difference between the height of outer rail and inner rail on a curve. Okay, It is a kind of, similar to, it is a kind of same as super elevation. Okay, so cant is difference between the height of outer rail and inner rail on a curve. Okay, so let's say limits of cant for yeah, for broad gauge it is broad gauge, and for group A, B, C routes it is 165 mm, 165 mm, and for group D routes, for group D and E routes it is about 140 mm. Okay, and for meter gauge it is mm, 90 mm, and for narrow gauge it is 65 mm. Okay, so yeah, this is it about limits of Kant. Let's move on to next thing. Next thing, which is very quite interesting, uh, which is steps for calculating Kant and VM. VM is our maximum permissible speed. So yeah, let's go that steps for calculating Kant and VM. Steps for calculating Kant and VM. Cm is equal to GV square upon 127 R. Second, this is first steps. These are all our steps. Okay, this is first steps to calculate Cm is equal to GB square upon 127 R. And then step second, that calculate Kant of slowest traffic. Calculate Kant of slowest traffic and denote it as CS. Okay, and in step third, add CE add CE plus CS. Okay, and step fourth, calculate Kant for equilibrium speed. Calculate Kant for equilibrium speed as C, give me a second. Come on, bro. What did happen here? Come on. Not give me a second. Give me a second. That yeah. So yeah, it in the steps for calculate the Kant for equilibrium speed C, and for in step five, check for in step five check for Kant efficiency. Check for Kant efficiency and by using CM and C. Okay, check for Kant efficiency by using CM and C. Okay, and in this, by checking this, if it is less than standard value, so if less than standard value, then then condition is okay. If it is not, then set it to the standard value. Of not, then oh, if not, then set it to standard. Oh my god, there's a less space. Standard value. Value. Yeah. Okay. So this is our This is our fifth step. Let's move on to the next step, which is our sixth step, which is that lowest value of first and second is the permissible count. Lowest value of from this and this is the permissible count. So value of lowest value of first and second is the permissible count. Permissible count. Basically, it is denoted as CA. And our steps seventh, add current efficiency and permissible count and calculate Vm by using formula. Vm is equal to 0.27 under root Ca plus Cd into R. Ca plus Cd into okay, Ca plus Cd into R. Okay, so these are the steps for calculating current and Vm. Vm is maximum permissible speed. So let's move on to the next thing, which is degree of curve. What it is? Degree of curve. Degree of curve. Basically, it is denoted as D. Okay, and we have formula for that. That D is equal to 1750 divided by R, where R is radius. Okay, so and for this we have also a diagram, which is something like this. This is 30.5 and this 90 angle. This is C. This is R. So by using formula that 30.5 upon 2 pi R is equal to D by 360. If you do the calculation, you'll get this formula. Okay, so yeah, this is it. And let's move on to the next thing, which is cosine of curve. uh, Give me a second so that I set the pages. Yeah, cosine of curve. Cosine of curve. Basically, it is we denote it as V. So V is equal to C square by 8R in meters, and V is equal to 12.5 C square by R in centimeters. Okay, so basically what is V? Let's draw a diagram so that we'll understand it very clearly. No man. Yeah. So yeah, this, let's say A, this is B, this is C, this one is D, and this one is E. Let's say this is C by 2, this is C by 2. Okay, and this is the point O. So this thing from here to here, this is denoted as cosine of curve. It is denoted as V, and this height from here to here is 2R. It is diameter also. Okay, so yeah, this is cosine of curve. And let's move on to another thing, the formula of super elevation here. Formula for super elevation. So formula for super elevation denoted as E. So we have formula for super elevation is equal to GV square upon 127R. 127R, where G is gauge, and we have values for G, and for we have value of G for broad gauges 1750 mm for broad gauge, and about 1058 mm for meter gauge. Okay, so do remember these values. And let's move on to the next thing, which length of transition. Length length of transition denoted as L. Okay, so basically we have formula L is equal to V max into E super elevation upon 198. Yeah, so by using this formula we'll get the value of length of transition curve. And basically, let if we talk about the type of transition curve, we have three type of transition curve, which is a Euler spiral, cubical spiral, and cubic parabola. And we have formula for that, for all of that thing. So if we talk about types of transition curve, and we talk about types of transition curve, then it is we have we have a Euler spiral, Euler's spiral, and for this we have formula phi is equal to L square upon 2 RL, and where this L is this L is the distance of any point from takeoff. Basically this L, let's write this separately. This L is distance of any point from takeoff point. Okay, and this L is capital L is overall length. So this is one of the type of transition curve. Another type is cubic cubic spiral. Another type is cubic spiral. We also have this. We have formula for this also, that LQ upon 6 RL. Okay, and other one is cubic parabola. For this we have formula that y is equal to x cube upon 6 RL, where x is horizontal coordinate and y is vertical coordinate. Obviously x is horizontal coordinate and y is vertical coordinate. Okay, this is it. So this is the type of transition curve, that a Euler spiral, cubic spiral, and cubic parabola also. So yeah, this is the thing. And let's move on to the next thing, which is shift. Let's say shift or shift. Yeah, shift. denoted as S. So we have formula for this also, that S is equal to L square upon 24 R. This is it in shift. And our next thing is widening of gauge on curves. So next thing is widening of gauge on curve. Gauge on curve. So we all have formula for this, that W is equal to 13 into B plus L to the whole square divided by R. Okay, where this B is wheel base, and B is 6 meter for broad gauge, and B is 4.88 meter for meter gauge. 0.88 meter for meter gauge. Okay, so this is the thing in widening gauge on curves. Okay, let's move on to another thing, which is length of transition curve. Basically, we have a table for this, that the length of transition curve. We already discussed that length of transition curve, and we have for table for this here. Length of transition curve. We have table for this, that criteria and desirable value, variable value, and minimum value. Okay, so our first criteria is rate of change of cant. Rate of change of cant, and its desirable value is Ca into Vm upon 125, and its minimum value is Ca into Vm upon 198. Okay, and our next criteria is rate of change of cant deficiency, that is CD. Is rate of change of cant deficiency. And its desirable value is CD into Vm upon 125. And its minimum value is CD into Vm upon 198. 198. And our another criteria is cant gradient. And it should not be greater than 1 in 720, and it should not be less than 1 in 360 for broad gauge. 1 in 360 for broad gauge, and it should not be less than 1 in 720 for meter gauge and narrow gauge. Should not be less than 1 in 720 for both meter gauge and narrow gauge. Okay, so this is the table. Do remember this table. Okay, so let's move on to another thing, that the lap of flange, which we have a formula for that also. What it is, lap of flange. Lap of flange, and we have formula for this, that 0.02 under root h square plus dh in meters, where h is depth of flange. Basically it is in centimeter. Okay, and our d is diameter in centimeter, and r is radius in meter. Yes, in meters. Okay, so yeah, this is it, lap of flange. And two basic theoretical thing, kind of numeric thing. Overthrow and end throw. So we have basic formula for overthrow. We have formula c square by 8r, and for end throw and throw we have formula l square minus c square. Shit, man, come on. That l square minus c square by 8r. 8r, okay. And where this c is total amount of wheelbase. This c and this c is total amount of wheelbase. Okay. So yeah, this is it about lap, flange, overthrow, and throw. Okay. Let's discuss about parameter of design of vertical curves. Okay, and type of gradients also. Uh, this will be our last topic in railway engineering. Let's discuss about parameter for design of vertical curves. Parameters for design of vertical curve. Design of vertical curves. Okay, we have formula for this, that L is equal to GI minus GJ into 30.5 small r. Basically, small r is rate of change of grade. Rate of change of grade. Okay, and gi and gj, these are grades. These are grades in percent. Okay, let's talk about minimum radius. So minimum radius for route A is 4000, route B for 3000, route CD is 2500, and for meter gauge all routes is 2500. So minimum, about minimum radius. So minimum radius is, we talk about route A. This is for broad gauge. Route A is 4000 meter. For route B it is 3000 meter. For route CD it is 2500 meter. For route C, D, and E it is 2500 meter. And for meter gauge, all routes have minimum radius of 2500 meter. Okay, and one more thing, one last thing in this topic is that type of gradient and grade compensation. And type of gradient, we have ruling gradient which have formula that p is equal to w sine theta. Oh man, p is equal to w sine theta, which is approximately equal to w into gradient. Okay, and if we talk about grade compensation, a broad gauge have 70 by r. Broad gauge have 70 by r, and meter gauge 52.5 by r, and narrow gauge have 35 by r, and narrow gauge have 35 by r. So yeah, this is all about railway engineering, geometric design of railway engineering. This is it for the syllabus of gate examination, for the syllabus of gate 22. Otherwise otherwise a railway engineering have very vast syllabus, but in gate syllabus there is only one thing from railway engineering, that the metric design of railway. So yeah, we done it, we completed the numeric portion of railway engineering. Soon very soon we'll discuss about the previous year questions of railway engineering. So yeah, till then do a lot of questions about the gate examination, about your various subjects, and so that you perform well in the real you'll perform well in gate examination. And best of luck for your gate 2022 examination. And till then, take care, goodbye, and thank you so much for watching this video. Thank you.